Now let's learn how to integrate trig functions. I know this can seem scary because, for some trig functions, we're going to have just definite ways to integrate, and others we're just going to have to start manipulating. So what if we look at tan? What if I wanted to integrate the tangent of x dx? Well, I don't know what the integral of tan x dx is. So the first thing I want to do is break it up into sine and cosine. Now, look at your denominator. Derivative of cosine is minus sine, so we're to a 1 over u situation. Let me let u equal cosine x. Then du is minus sine x dx. Oh, this is good. So let me put a negative here and a negative here, negative 1. So this becomes minus 1 times the integral of du over u, which is minus 1 times the natural log of the absolute value of u plus c. Now this is minus 1 times the natural log of the absolute value of cosine plus c. I can rewrite this as a natural log of 1 over the absolute value of cosine x. That doesn't buy me anything. Do it, don't do it, doesn't matter. If you're going to do something like this, do not make a mistake, all right? Because you get counted off for making algebraic mistakes. But because it doesn't get you anything, you won't be counted off for not doing it. Okay, you give this one a go. Turn the tape back on when you're done. Now, let's look at the secant formula. The secant is 1 over cosine. Now, that's not very helpful. Using that substitution won't help. So sometimes you have to manipulate this. What if I write this as the integral of secant x and I multiply by 1? But I'm going to choose my 1 to be very carefully crafted. So what if I multiply by secant x plus tan x? Yeah, that wasn't what you were expecting, was it? So I'm going to do secant divided by secant secx plus tan x. All right, now I can do this, and I'm good, right? So let me multiply this out. This is the integral of secant squared plus secant tangent divided by secant plus tangent. Now, did I make my life easier or did I just make it harder? Well, now I've got an ugly denominator, or I've got a denominator, so let me let u equal secant x plus tangent x. Now, what is du? Well, du then becomes, oh my goodness gracious, secant tangent plus secant squared. Hey, that was kind of cool, kind of slick. So this becomes the integral of du divided by u. So this is a natural log of the absolute value of u plus c. So this becomes the natural log, oh my gosh, what was u again? Secant x plus tangent x plus c. Now, it's not entirely obvious why you would do that to start with, but hint, that is one way to do these problems. Why don't you give this one a go? Turn the tape back on when you're done. Now, here are 6 basic trig functions and what their integration is. The integral of sine is minus cosine, and integral of tangent is minus log of the absolute value of cosine. The integral of secant is the log of the absolute value of secant tan. The integral of cosine is sine. The integral of cotangent is log of the absolute value of sine. And the integral of cosecant is minus log of cosecant plus cotangent. Memorize them. You're going to have a quiz next time. Okay, now what do you do when you're trying to integrate trig functions like this? Can I do a u substitution? No. I don't have anything in the denominator. What if I use an identity? Sometimes you're going to have to use identities. What if I say that secant squared x is 1 plus tangent squared x? Can I do that? Well, of course I can. So this becomes the integral from 0 to pi over 4, the square root of secant squared, which is just secant. As it turns out, we're positive here, so we don't have to worry about our absolute values. All right, so the integral from 0 to 2 pi of secant is the natural log of the absolute value of secant x plus tangent x, evaluated at 0 and pi over 2. All right, so this is the natural log of, what is this? Square root of 2 plus 1 minus the natural log of, 1. That's 0. So this is just the natural log of the square root of 2 plus 1. All right, you can put this in decimal form. Again, give it to 3 decimal places, 0.881, if you put this in your calculator. Give it a go. See if you can do this one. Now the last thing we're going to do is find the average value. Find the average value of f of x equals tan x on the interval 0 to pi over 4. Now remember, the average value of a function is equal to 1 over b minus a, the integral from a to b, f of x dx. So this is 1 over pi over 4 minus 0 times the integral from 0 to pi over 4 tan x dx. So this is 4 over pi times the integral from 0 to pi over 4 tan x dx. All right, we now have our handy dandy formulas memorized. This is the minus the natural log. I'm going to put the minus sign out here. The natural log of the absolute value of cosine x. And this is going to be evaluated at 0 and pi over 4. So this is minus 4 over pi times the natural log of the square root of 2 over 2 minus 1. Whoops, log of 1. Now that's 0. So this becomes a very ugly number. Natural log of the square root of 2 over 2. Do not bother to simplify this into 1/2 log of 2 minus log of 2 and all of that. If you put this in your calculator, you can get an answer of about 0.441. All right, give it a go. When you're done, turn off the tape, finish your homework.